Now let us discuss addition and subtraction of surds and how to change the surds into like surds by using law of exponent. Which law? Fifth law, which we have discussed just now, in which we can change the order of the surd by multiplying the index of the surd and index of the radicand by the same positive number. Now let us see one example. You have given root 32 plus root 200 plus root 128. We will reduce them. 32 can be written as 2 into 2 into 2 5 times. So, root 32 will be under root 2 into 2 into 2 into 2 into 2 5 times. Similarly, under root 200 can be written as root 2 into root 2 into 2 into 5 into 5, and under root 128 can be written as under root 2 into 2 into 2 5 times multiplied by 5 into 5. So, this is equal to, in the under root 32 can be written as 4 root 2. Similarly, root 200 can be written as 10 root 2, and root 128 can be written as 8 root 2. Now, in all the three numbers you have irrational factor common. What is that irrational factor? That is under root 2. So, we can take that irrational factor common, and inside the bracket we will get 4 plus 10 plus 8, which is equal to 22 root 2. So, the whole expression can be reduced to 22 root 2. This is how we add 2 or more surds. Let us see the subtraction or the difference of the surds. Example is 45 root 6 minus 3 root 216. Again 45 root 6 will be written as it is, and under root 216 can be written as 6 into 6 into 6. And since it is under root 6 into 6 into 6, you can take 1 6 outside and you will be left with 6 root 6. So, instead of writing 216 under root, we will write 6 root 6, and by writing 6 root 6, 3 is outside. So, 3 will be multiplied by 6 and you will get 18 root 6. Now, in both the surds you have under root 6 common, which is the irrational factor. So, we will take that irrational factor outside the bracket, and inside we will get 45 minus 18 root 6, which is equal to 27 root 6. So, this is how we add or subtract surds. Let us see one more example in which we are taking both the operations at the same time, that is operation of addition and subtraction. Show that 24 root 45 minus 16 root 20 plus root 245 minus 47 root 5 is equal to 0. Now, here you have given two sides, one is left hand side, other is right hand side. We have to prove that left hand side is equal to right hand side. Let us start with the left hand side. 24 root 45, which can be written as 24 into 3 root 5 minus 16 root 20, which can be written as root 20 can be written as root 4 into 5, and taking 2 outside you will get 16 into 2 root 5 plus 245. Root of 245 can be written as 7 root 5 minus 47 root 5 as it is, because it cannot be simplified further. Now, in all the numbers, in all the surds, you find the irrational factor is common, and that irrational factor is root 5. Now, we will take root 5 common, and inside the bracket we will get 72 minus 32 plus 7 minus 47, which will give you root 5 into 0, and any number multiplied by 0 is always 0. Therefore, product of root 5 and 0 is 0, which is equal to right hand side. Hence, we have proved that 24 root 45 minus 16 root 20 plus under root 245 minus 47 root 5 is equal to 0. So, we see that in case of addition and subtraction of surds, we take the irrational factor common and then we add and subtract. Let us see multiplication and division in surds. Surds can be multiplied or divided if they are of the same order. For example, we have under root 3 and under root 2. Both are square root, therefore, they can be multiplied and they can be divided also. Fifth root of 16 and fifth root of 32, both have fifth root, therefore, they can be multiplied and divided. Similarly, nth root of x and nth root of y, they can also be multiplied and divided because both have same order and that is n. Let us multiply and see one example. 2 under root 50 multiplied by root 32 multiplied by 2 root 72. 2 under root 50 can be written as root 25 into 2. Root 32 can be written as root 16 into 2 and 2 root 72 can be written as 2 root 36 multiplied by 2. 2 root 25 into 2, the square root of 25 is 5. So, we can take 5 outside and we can write it as 2 into 5 into root 2. Root 16 into 2 can be written as 4 root 2 because 4 is the square root of 16 and root 36 into 2 can be written as 6 root 2 because 6 is the square root of 36. Now, in all the three surds, we find that the irrational factor is common, that is under root 2. We take under root 2 outside and inside the bracket we are left with 10 into 4 into 12. When we multiply 10 into 4, 40, 40 multiplied by 12, we get 480. Therefore, this is equal to 480 root 2. Let us see one example on division also. Divide 2 under root 24 by cube root of 320. Now, here we have two surds. In root 24, the order of the surd is 2 and in cube root of 320, the order of the surd is 3. So, before we divide these two numbers, we will have to change their order. 2 root 24 can be written as 2 6 root of 24 cube. Now, observe what we have done in this example. We have multiplied the order of the surd 2 by 3 and at the same time we have multiplied the order of the radicand by 3. The power of 24 was 1 and now we have multiplied the power of 24 by 3. Likewise, we had cube root of 320. The cube root of 320 has been changed to 6th root of 320 square. The order of the surd was 3, 3 is multiplied by 2 and at the same time the index of the radicand is also multiplied by 2. Therefore, it is reduced to 6 cube root of 320 square. Now, both the numbers have same order, that is 6. So, applying the formula that nth root of a divided by nth root of b gives you nth root of a by b, we can solve it 2 into 6 root of 24 into 24 into 24 3 times divided by 320 into 320 2 times. Further, 24 can be written as 8 into 3 and 320 can be written as 8 into 8 into 5. So, simplifying it, we get 6 root of 27 by 200. So, we see that how we multiply and divide two surds. Let us see the comparison of surds. Now observe one thing here, that whenever you compare two or more certs, or you write the given certs in ascending or descending order, reduce the given certs to the certs of the same order. We can compare them, we can write them in ascending or descending order. So learners, up till now we have learned how to add, how to subtract, how to multiply and how to divide two or more given certs, and how to change the order of the given certs. If you have any query, you can write to us, you can call us on the numbers being flashed on the screen.
जीवन ये प्रकाशित करने, राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने। जीवन ये प्रकाशित करने, राहों को आलोकित करने,
धन साधन समय की सीमा से विद्यालय जो मुक्त हो, धन साधन समय की सीमा से विद्यालय जो मुक्त हो।
कभी पढ़े हम कहीं पढ़े, वे विषय की लोच से युक्त हो,
कभी पढ़े हम कहीं पढ़े, वे विषय की लोच से युक्त हो।
मित्रों हम उठे और जागे,
मंजिल आने की ध्वनि सुने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने।
जीवन ये प्रकाशित करने, राहों को आलोकित करने।
राष्ट्रीय मुक्त विद्यालय का है द्वार खुला सबकी खातिर। शिक्षा परीक्षा का अवसर एक बार ही क्यों मिलता फिर।
शिक्षा और परीक्षा का अवसर एक बार ही क्यों मिलता फिर। दुनिया में इसके केंद्र बात,
कोई मन चाहा केंद्र चुने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने। कोई मन चाहा केंद्र चुने, हम अपना दीपक स्वयं
Now we have come to the last part of this chapter, which is rationalization of surds, and this part will apply up till now what we have learned. Now look at the rationalization of surds. You have root 5 multiplied by root 5, which gives you root 5 into 5, that is root 25, which is 5. Now you have taken two surds here. Under root 5 is a surd, under root 5 is a surd. You have multiplied the two surds, and on multiplication you get 5, which is a rational number, which is not a surd. Let us see the second example. 7 raised to power 1 by 3 multiplied by 7 raised to power 2 by 3, which is equal to 7 raised to power 1 by 3 plus 2 by 3, which is equal to 7 raised to power 1 or 7. Now again look at the example, that you have taken two surds and product of these two surds is a rational number. Let us see the third example. 9 raised to power 4 by 7 multiplied by 9 raised to power 3 by 7, which is equal to 9 raised to power 4 by 7 plus 1 by 7, which is equal to 9 raised to power 1 or 9. Again we have taken two surds, the product of these two surds is 9. When we multiply two surds and get the product as rational number, then each surd is called the rationalizing factor of the other surd. In this case, under root 5 is a rationalizing factor of under root 5, 7 raised to power 1 by 3 is a rationalizing factor of 7 raised to power 2 by 3, and 9 raised to power 4 by 7 is the rationalizing factor of 9 raised to power 3 by 7, and vice versa also. So you can say that rationalization is the process of converting surds into rational numbers. Note, x plus under root y and x minus under root y, surds of this type are called conjugate surds. One is x plus root y, other is x minus root y. Now just think, if we add these two surds, that is we add x plus under root y and x minus under root y, what you will get? 2x. And if you multiply these two surds, x plus root y multiplied by x minus root y, what you will get? Applying the formula a plus b into a minus b is equal to a square minus b square, you will get it equal to x square minus y. So what have you observed? That when you add two conjugate surds or you multiply two conjugate surds, you always get a rational number, and rationalization is done in an expression on their denominator only. In the denominator, we always multiply the denominator by the conjugate of its denominator, and when we multiply the denominator by its conjugate, obviously we will multiply the numerator of the expression also by the same number. Let us see this thing in the given examples. Let us find the rationalizing factor of root 20. Root 20 can be written as 4 into 5, which is the square root of 4 is 2. So we can take 2 outside and we will get 2 root 5. So the rationalizing factor of root 20 is root 5, because when you multiply 2 root 5 by root 5, you will get 10. And what we have learned, that rationalization is the process of converting surds into rational numbers. Let us see the second example, root 75. Root 75 is a surd. We have to multiply it by a number so that it converts into a rational number. Now root 75 can be written as root 25 into 3. Square root of 25 is 5. So it can be written as 5 root 3. Now when I multiply 5 root 3 by root 3, I will get it 5 into 3, which is 15, and 15 is a rational number. That means by multiplying root 75 by root 3, I will get a rational number. Therefore, root 3 is the rationalizing factor of root 75. Let us see one expression in which I have numerator and denominator, and I want to find the rationalizing factor of this expression. The expression is root 3 plus root 5 divided by root 3 minus root 5. Now, look at the denominator of the expression. It is root 3 minus root 5. Tell me what will be the conjugate of root 3 minus root 5? It will be root 3 plus root 5. So, in the given expression, I will multiply the numerator and denominator by root 3 plus root 5. Let us multiply it. Root 3 plus root 5 divided by root 3 minus root 5 multiplied by root 3 plus root 5 divided by root 3 plus root 5. Now, in the numerator, you have root 3 plus root 5 multiplied by root 3 plus root 5. It is just like a plus b into a plus b. And what is the product of a plus b and a plus b? It is a plus b whole square. Therefore, this will be root 3 plus root 5 whole square. Now, see, look at the denominator. Denominator is root 3 minus root 5 and root 3 plus root 5. These are conjugate. Therefore, the product will be, applying the formula, a plus b into a minus b is equal to a square minus b square. Therefore, this is equal to root 3 square minus root 5 square, which is 3 minus 5. Now, in the next step, we have root 3 plus root 5 whole square divided by 3 minus 5, which is equal to a square. A square is 3 in the numerator, 5 under root 5 square, which is 5, plus 2 into a into b, it is 2 into root 15 divided by, in the denominator you have 3 minus 5, which is equal to minus 2. Therefore, this is 3 plus 5, 8 plus 2 root 15 divided by minus 2, which is equal to minus 4 divided by minus 15, because 2 is the common factor in the numerator and denominator, and you can cancel the numerator and denominator by 2. Let us see one more example. In this example, we have given that if 2 plus 5 root 7 divided by 2 minus 5 root 7 is equal to x plus root 7 y, then find the value of x and y. So, we start with the left hand side, we simplify it, we rationalize it, and then we will compare the left hand side with the right hand side and will find the value of x and y. For rationalizing left hand side, you have 2 plus 5 root 7 divided by 2 minus 5 root 7. So, with what number we will multiply this expression so that its denominator is converted into rational number. So, we will multiply the conjugate of the denominator. The denominator is 2 minus 5 root 7. Therefore, its conjugate will be 2 plus 5 root 7. So, in the given expression, you multiply the numerator and denominator by 2 plus 5 root 7 and 2 plus 5 root 7. In the numerator, you have 2 plus 5 root 7 whole square, and in the denominator, you have a square minus b square, that is 4 minus 25 multiplied by 7, which is equal to minus 171. So, in the numerator you have a square, that means 2 square 4, b square, that is 5 into 5 into 7, which is 175, and 2ab, it is 20 root 7 divided by minus 171, which is equal to 175 and 4 is 179 plus 20 root 7 divided by 171 and whole with the negative sign. This is equal to minus 179 upon 171 minus 20 upon 171 root 7. So, this is equal to minus 179 upon 171 minus 20 upon 171 root 7. This is the left hand side. We want to find the value of x and y. So, we will compare the left hand side with the right hand side, which is equal to x plus root 7y. Comparing the left hand side and right hand side, you will get that x is equal to minus 179 upon 171 and y is equal to minus 20 upon 171. So, this is how we rationalize the given numbers, given expressions, by multiplying the number by such a number so that the surd is converted into rational numbers. And if we have given expression in the form of p by q, we always multiply the denominator by the conjugate and numerator also with the conjugate of the numerator. So, learners, today we learned about surds, their simplification, their 4 fundamental operations. Now, if you have any query, you can write to us, you can call us on the numbers being flashed on.
जीवन ये प्रकाशित करने, राहों को आलोकित करने, हम अपना दीपक स्वयं बने, हम अपना रास्ता स्वयं चुने।
धन साधन समय की सीमा से विद्यालय जो मुक्त हो,
धन साधन समय की सीमा से विद्यालय जो मुक्त हो।
कभी पढ़े हम कहीं पढ़े,